Right, what is up, guys? My name is Dylan, and I'm gonna start making some basic computer science tutorial videos and educational stuff for YouTube because I feel like a lot of the stuff out there is somewhat subpar quality, and it just sucks, like not having enough resources to study from. And it seems like a lot of the videos I found they're okay, but it feels like they're, I guess, routine. The teaching doesn't quite work or didn't quite work for me, and I feel like I have a really particular fashion that I have to learn in. So I figured I'd make some sort of videos that I think encompasses that mode of learning. But so digital logic is important in your learning of computer science, or a lot of electrical engineers are involved too. But we need to learn the language of logic design. For example, how can we describe circuitry in basic mathematical ways? What sorts of ways can we minimize the logic involved in implementing some sort of design? There's a lot of really basic stuff like switches and logic gates that help you determine the flow of information. And there's some tools out there, such as breadboards or CAD software, that help you kind of implement and learn some more about this. So, with this topic, I intend to be coming out with hopefully a few videos a week. The spring semester starting 2017 in about a month and a half or so. So, hopefully, I get enough stuff out there for people who may use that when that comes up. So, where did the study of digital logic and all this sort of stuff begin? Well, in 1702, the German mathematician Gottfried Leibniz, I bet I wrecked it too, but I will link the wiki article to his thing. He developed logic in a sense with his work on the binary or base 2 number system. It turns out that computers, as we know them today, heavily rely on the base 2 number system, and it makes things way simpler. And you'll see later on in another video trying to compare what a base 2 system versus a base 10 system. So imagine if computers used decimal numbers instead of binary numbers, and it could make things really confusing. There's also another number system called hex or octal. There's two more actually that are widely known. There's a lot of different systems, but for computers, those are the ones you might run into more. Well, through this video series, I intend on documenting how that sort of stuff came out and how they relate to each other. And it's pretty interesting and new stuff. Other topics of interest, like astronomy, have been around for thousands of years, since the Egyptians and even before. Yet the study of computing is still pretty young, and there was some old computing technology out there, and I might even make a video about that, like how we've evolved through the years. I think it was called an abacus, the thing with the rows and the balls. It was another way to do a calculation. But anyways, why should you care about this in the first place? A basic understanding of logic circuits is an absolute fundamental for the electrical engineers and computer scientists and computer engineers and people in other such related fields. Logic circuits are used to develop and build hardware. We build big things with really tiny components. Everything behind what's in a modern CPU or on a motherboard is very dense, and there's a lot of stuff on it. There's something called Moore's Law that I'll cover in the next video that kind of shows the growth of technology. But that'll be it for this, and it's just a quick introduction. I've got a website, and I'll link it below, and it'll have some PDF documents and other such stuff available on there for this. And of course, I'll also link a lot of really cool stuff too. Really interesting Wikipedia articles about different mathematicians or computer scientists and what their work involved, or really interesting articles that I've come across that kind of shows you that we are kind of on a bleeding edge thing as far as the history of mankind. But just stuff I think is awesome. Plus, I'll also link some basic Boolean algebra type things and resources for you to kind of read up on that, see what's up with it before hopping into the next few videos, because it's quite an important aspect. But that'll be it for now. Make sure you check those links out because they are going to be good and very useful to your further understanding. Um, if you're feeling a bit awkward with algebra or things that say you haven't looked at in a few months, kind of weak on it, like I can easily get weak with my Boolean algebra if I don't keep studying it, or doing binary subtraction and addition, division, stuff like that. You got to keep on top of that and practice it all the time. And the thing I do a lot is with the calculator, I'll practice long division with decimals, with hexadecimal, and just practice that stuff and make sure you get up onto speed with it, because it will help understanding the stuff we're studying, looking at how it behaves, a lot easier if you're comfortable with your math. But I'll see y'all in the next video, and please subscribe if you can.